Good afternoon, guys. Welcome back into my channel. So in this lab, we are going to configure GRE tunnels. So the GRE tunnel overview, it stands for Generic Routing Encapsulation, GRE. So tunnel is ideal for forwarding internet-bound traffic from your corporate network to the Zscaler service. So GRE is a tunneling protocol for encapsulating packets inside a transport protocol. A GRE capable router encapsulates a payload packet inside a GRE packet. Now, if you follow along here in this lecture, you would see, so GRE is a tunneling protocol that provides connectivity to a wide variety of network layers. Network layer protocols by encapsulating and forwarding packets over an IP-based network. GRE was originally created to provide transport for non-routable legacy protocols such as inter-network packets exchange, IPX, across an IP network, and is now more commonly used to overlay for IPv4 and IPv6. So the GREs have many uses. For example, they can be used to tunnel traffic through a firewall or an ACL or to connect discontinuous networks. And they can even be used as networking duct tape for bad routing design. The most important application is that they can be used to create VPNs. Now, when a router encapsulates a packet for a GRE tunnel, it adds new header information known as encapsulation to the packet, which contain the remote endpoint IP address as the destination. The new IP header information allows the packet to be routed between the two tunnels endpoints without inspection of the packet's payload after the packet reaches original packet is forwarded out of the remote router. Now, there go the original packet. As an example, it says protocol 1 is equal to ICMP, 6 is equal to TCP, 17 is equal to UDP. So if you look here, you would see, so the GRE tunnel configuration, that's what we have here. So it says illustrated, the topology where router 1 and 2 or use their respective ISP, which is an internet service provider, for gateways and stuff. So, show IP route. So create a tunnel, channel interface, consider as follow, command. So create the tunnel interface by using the global configuration interface tunnel. So that's just different tags on how to make your steps on creating a GRE tunnel. So now, this is very important. It says that encapsulation overhead for tunnel. So the GRE without the IPsec is 24 bytes. Tunnel header size and tunnel type. So DES/3DES IPsec transport mode. So it's 18 to 25. Now, they have the GRE configuration example here, guys. So if you follow along, you would see, so verifying the tunnel, trace route, and bang, bang, bang. So problem with overlaid network recursive routing. So, okay, guys, so let's go ahead and start the configuration for the GRE tunnel. Now, if you may ask, like, how does the GRE tunnel works? So GRE works by encapsulating a payload that is an inner packet that needs to be delivered to a destination network. Inside an outer IP packets, the GRE tunnel endpoint send payload through GRE tunnels by routing encapsulated packets through intervening IP networks. So how do you characterize GRE tunnel? By encapsulating packet within other packets, it is called tunnel. GRE tunnels are usually configured between two routers, which, I mean, with each router acting like one end of the tunnel, and the router are set up to send and receive the GRE packets directly to each other. Now, what is the benefit of using the GRE tunnel? Well, the advantage of the GRE over the other tunneling protocol is that it can encapsulate broadcast multicast traffic, multicast streaming or routing protocol, and other non-IP protocol. The GRE packet can be protected by using Internet Protocol security, which is IPsec, ensuring confidentiality and integrity of the tunnel traffic. So maybe you may want to ask, what is the difference between the VPN and the GRE tunnel? Well, while many might think that the GRE IPsec tunnel between two routers is similar to a site-to-site IPsec tunnel VPN, it is not. A major difference is that the GRE tunnel allows multicast packets to traverse the tunnel, whereas the IPsec VPN does not support multicast packets. So the last question before we start our lab configuration today about GRE tunnel, maybe you may ask, what layer is GRE tunnel? Is it layer 2 or layer 3? Well, layer 2 GRE tunnel, GRE is an IP encapsulation protocol that is used to transport packet over a network. Now, by the way, what are the three main types of tunnels? Well, there are three basic types of tunnel construction. Yep. Now tunnels. So network connection is done by via the GRE tunnel IP protocol number 47 list of IP protocol numbers. So since GRE is an IP protocol, it is not based on either TCP or UDP. It has no concept of port. Go ahead and pull up Packet Tracer and start our configuration about the GRE tunnel today. Make this big and let's start getting our hands dirty as usual. So if you would go on router A, which is this router here, and say you want to ping, so ping from all, ping router A from router, let's say you want to ping router A from router B. By the way, let's look at this. Let's say enable show IP and BR. So we get this, that's 6.1.1. So let's go ahead from router B. Let's go ahead and ping router A. It says and ping 192.168.1.1. So say, for instance, you're a network administrator for a company which wants to set up the GRE tunnel to a remote office. Now, both networks are locally configured. You need to configure the tunnel and static route. Now, you see we have a successful ping, right? Now, from router B, again, PCA. So attempt to ping the IP address from PCA, or PCA from B. Let's say you want to test PCA from PCB. Okay. Let's look at here. Let's say conf. So PCA is .2. Let's go ahead and do that. Not terminal, but common. Says ping 92.168.1.2. So, okay. So after the configuration, we're going to ping that again. So let's configure the tunnel 0 interface on router 1, which is router A. Okay. So let's go ahead and do conf t. Then we could do it gigabit. Let's do internet interface tunnel 0. So we're gonna set the IP address as indicated in the addressing table. So the addressing table that we work with is this addressing table here, guys. And there go the lab objective, says verify, router, connectivity, configure GRE tunnel, and verify the PC connectivity. So let's go ahead and go back here. We're gonna do IP address, IP address 10.10.10.1, Then we have a subnet mask of 255.255.255.252. Oh, I see. I see. It's all my fault. So this should be 0, but I put a O. Right? So let's do this and then go. Now, we're going to set the source and the destination for the endpoint of tunnel 0. So why don't we go ahead and do tunnel source. Let's do, what was it that we had? So we have serial. So let's do serial the 0 /0. Okay, so now we're gonna do the tunnel destination with the IP address of 209. So let's do tunnel destination 209.165.122.2. Okay, so you see you got a message that says that line protocol of the interface.geo change state is changed to off. So far so good. Now, we're gonna configure tunnel 0 to convey IP traffic over the GRE. So let's go ahead and follow along with me. We're gonna do tunnel mode GRE IP. So now the tunnel 0 interface should already be active. In the event that it is not, we can treat it like any other interface. Now, to be on the safe side, we might just as well open up the port with the command that no shutdown. Right? Now, let's go ahead and repeat the same. Let's go ahead now and repeat the same. Let's go ahead now, guys, and repeat the same. Go ahead and repeat the same process for our two. What do we do? Bang, 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 right there. So R2, which is considered as RB, we're gonna do, let's do conf T, and then we'll be doing NFS, tunnel CO. We're gonna go a little bit faster since IP address. So we're gonna do 10.10.10.2, and then we can do, let's go ahead and do 255.255.255.252, right? Okay, then we're gonna do what? Tunnel source. The source of the tunnel is serial 0/0/0. Then we're gonna do tunnel destination is 64. You may wonder where we get these IP addresses from. Let's go ahead and show you again. There we go. So we work with the IP addresses that we've been provided. They go to 64 that we type in here. So it will be 64.103, up 64.103.211.2, right? Now, let's do tunnel tunnel mode GRE IP. And then let's making sure that we open the port. So there's no shutdown. No shut. So no shutdown. Okay, guys. So now on step 3, we're going to configure a route for private IP traffic. So establish a route between 192.168.x.x network using the 10.10.10.0/30 networks as the destination. So let's go ahead and do that on both of the routers. Since we're already here on router 2, we might just as well do it on 2, and then we'll do it on 1. So let's do IP. As a matter of fact, to be on the safe side. So let's do IP route. Did you take it? Okay, so IP route router 2 will be 192.168.1.0. And then we have what? 255.255.255.0. And now we get the 10.10.10.1. Okay, bingo. Let's go ahead and do the same on router, sorry, on router A as well. So on router A, let's make it bigger so everybody can see. Let's do IP route 192.168.2.0, 255.255.255.0, 10.10.10.2. Okay, so now if you verify the router connectivity, you should be able to get a ping from PCA. Ping PCA from PCB, right? So let's go ahead and test this as we did. Let's go. We have PCB here. Let's go on command. Let's make a space and make this bigger and make an up arrow and see if we get a successful ping now. Now attempt to ping the IP address of PCA from PCB. The ping should be successful. So there we go. We have a successful ping here. Now with the trusted path from PCA to PCB, we could trace the route from PCA to PCB. So attempt to trace the path from PCA to PCB. Note that the lack of public IP addresses in the. So basically, that's set for this. That's set for this lab. So guys, this is not rocket scientist. This is how you configure the GRE configuration. The GRE tunnel. I appreciate you guys will follow along with me. Stay tuned for another video on the CCNP Enterprise. Again, thank you. Let's stop sharing and let's end this session.